Hello, everyone. It is another Monday, so it's another workshop to help power your application development. So we're in full swing of our hackathon right now. I don't know if you know this, Andrej. We're doing a 6-week hackathon, 100K in prizes, and then bringing in super interesting people like yourself to help learn how to build dApps better. But before I get into it, I guess if you could introduce yourself, let everyone know who you are, what you're doing.
Yeah, of course. Thanks for inviting me. It's a pleasure to be here. Yeah, my name is Andrej. I work as a blockchain engineer here in the DevRel team at Chainlink Labs. I've been with Chainlink for more than 3 years, I think, doing a lot of educational content, creating tools for developers. Some of those tools I will show you today. And yeah, I'm really excited to showcase you one of our latest products, which is Data Streams. I know you've probably been familiar with Chainlink regarding getting price data on various different blockchains, but there's much more. And DataStream is one of the pretty cool products for a couple of interesting use cases, and it's now live on Scroll. So I'm really looking forward to this workshop.
Yeah, awesome. So, I guess interesting use cases. I always like going into that because it helps kind of frame our reference of thinking. Do you want to talk about it? I'm not sure if it's already in your slides, but I do want to like hone in on like what can I use data streams for?
Yeah, it is in my slides, but I'll nevertheless do like a quick recap. So basically, data streams is a way to get the price data much faster, like in less than the seconds, and it's extremely like compared to traditional data feeds where you're literally reading price data from blockchain and from smart contract on chain, which sometimes can be outdated if you don't care about those tiny little decimals, whatever. But like with data streams where you can like get price data almost instantly, it unlocks a couple of new use cases like perpetual futures protocols or automated market making or options protocols or prediction markets, which are quite popular in couple of or became quite popular in a couple of previous months. So stuff like that is definitely a use case for data streams.
Okay, very cool. So, are you saying it's like similar concept to what you would use oracles and price feeds for, but it's much faster?
Yeah, so we have like traditional oracles are like push based.
Right.
Basically, oracles doing their own thing, and when there is a trigger, they will like push new price update on chain, and then consumers just read directly from smart contract. This thing does exactly the opposite. You can get the price data, the latest price data at that moment whenever you want, or you can subscribe to the WebSocket stream of new prices constantly. I'll show you that as well. And then when you want to use it on chain, you just get that blob or bytes data returned from the oracle, verify against the verifier smart contract on chain, and then use it. So it's literally like use it when you need it the most. And there is like a short period of time when the price is like legit. After that, it just expires. You need to get a new one. So it's
Right.
faster. Yeah.
Cool. Well, I mean, I think we can probably dive into it. I do have, I guess, one more follow-up question.
Yeah, sure.
Also don't know if it's in your slides, but is there like a I would use this one over that one? Like when would I use data streams versus when I would use oracles?
Uh,
Um,
yeah, like you will use data streams when you carry when you like carry about the precision. So with traditional price feeds, because it's not efficient to write new prices data on each block on chain, etc. There are two basically uh, parameters. One is like time threshold, is like never like there was a new price update in 30 minutes, let's do another one. The second one is like price threshold, and that price threshold is like depends from feed to feed, but let's say it's like 0.5%. So if the new price is greater or lower than 0.5 compared to the last written one on chain, at that new price will be written on chain. However, if you care about more decimal places and if you care about changes that are like less than those 0.5%, then data streams is definitely for you. Or if you want to quickly settle new trades, for example, GMX is one of the users of data streams in production, for example, then like data streams are must.
okay, cool. And then does this protect against MEV or like Oracle extracted value? at all?
Yeah, like because if you want to use it on your front end or whatever, like you can
Hmm.
just consume it, doesn't matter. But if you want to use it on chain, then you need to go through the process of verification. You literally call the verifier smart contract to verify the blob, and it will, like, if it's okay, it will return the unverified price, whatever. If not, then you can handle that gracefully. But the thing is that in smart contract, you can call all of these functions, multiple functions, like plus your to settle the trade or whatever you want to do with the price in the same transaction, and that way you are not at risk to get MEV'd, because again there is no like a DEX or pools that you can be
Right.
sandwich attacked or whatever. It just came from the Oracle directly. It's like the aggregation of all price data across multiple different protocols.
Awesome. Perfect. Okay. Thanks for letting me percolate on that
Yeah.
for a bit. But I know you have slides. I want to get into it and learn more, I think, in depth.
Yeah, sure. So I'm gonna stop. I'm actually start sharing my screen. I have slides. I actually have some repo that I created just for this occasion. So I'll just gonna go quickly through slides, and then I think it's more beneficial to just spend some more time in the actual repo because it's just fresh news for this occasion. I want
Right.
to showcase you a couple of new stuff from for data streams. So yeah, the title is to build with Chainlink Data Streams on Scroll. This is myself, as you already, I already introduced myself. This is my Twitter handle Andrej_dev. If you want to follow up with when any discussion afterwards, and I'm also writing this newsletter called Smart Contract Design Patterns, where I'm talking about Solidity and some general design patterns in smart contract development. And I hope one day it'll become a book, but for now it's a newsletter. So if you're interested in that kind of stuff, you can always subscribe. Enough about me. What I wanted to share with you is data streams, but data streams are just a subset of the broader blockchain services platform, which is Chainlink. So if you're being early, like enough in the space, basically Chainlink started as just as an Oracle service to provide price data back in 2020 when DeFi summer started to bloom, and it basically enabled a bunch of really cool and popular use cases like lending and borrowing. For example, Aave is one of the most famous and popular names that are using Chainlink in production for all these years. But since then, the Chainlink as a platform evolved, and with additional multiple different services, it's literally like a one-stop shop for you to do anything on chain with smart contracts that connect both on chain and off chain worlds. So besides data feeds, there are data streams, which we're going to talk about, VRF for randomness, automation, which I'm also going to mention today as well. Automation is for automating various different tasks. Proof reserve feeds also useful for RWA use cases and examples. For example, Chainlink functions, which allows you to make HTTP GET, POST requests, any type of computation using JavaScript. For now, there will be more languages. And finally, probably the most important one, CCIP, because it's Chainlink for a reason to link all of these chains. And CCIP stands for Cross-Chain Interoperability Protocol, where you can send cross-chain messages, both tokens and data, in a completely decentralized and secure manner between different blockchains and even different types of blockchains, not just like talking to the layer one from layer two, for example, but you can also connect with another layer twos if you want, etc. So CCP is probably my favorite one. But today we're going to talk about Chainlink data streams, and I'm going to actually share, instead of this slide, I'm going to share my whole window because I want to show you something more. So yeah, here it is. If you go to home.chain.link, this is the website of the Chainlink platform, and you can also connect your wallet if you want to start, so you can see like your disconnect. Yeah, let me go through the flow again, so you can see your whole history and analytics of previous action on on the Chainlink platform. So these are my requests, whatever. But if you toggle this menu over here under products, you'll find all these products, and we are interested in data. That's also, you can see here, data.chain.link, the URL I put on slides. And here, besides traditional data feeds, we also have Data Streams panel. And if I go to Data Streams, we're going to see these low latency data. You can see in real time how price data changed. We're also, besides the mid price, has also this bid and ask price, which I'm going to talk in a minute to show you what those means. But if you, for example, want to check the BTC in terms of USD, you can even have the live view over here, and you can see Bitcoin in terms of US dollars dancing on your screen, because this is from this moment in time when you went through this page, the live movement of this price. You can also toggle historical reviews, of course, and you can see on all of this blockchain, which is available. Scroll is of course there, plus some other info, etc. So the thing is that here, probably the most important thing is this feed ID, which is unique identifier of this particular stream. And this one is the same across all of these chains, across all of these mainnets, and the different one across all of these testnets. So you can maybe save some gas or optimize your smart contract design to leverage that particular info. The thing that will be different is that verifier smart contract that I was talking about, and then we are going to use to verify the whether these price reports are actually legit or outdated or wrong or in any manner, etc. So basically, this view is a connection now to the continuous WebSocket stream of WebSockets of new prices, and we can see it comes. Its calculation comes almost instantly. Pretty much the same thing that Oracle Dons are doing with traditional price feeds. However, there are those thresholds, and based on those thresholds, only that particular price will be written on chain. However, with Data Streams, it's much faster, and you can consume it instantly. I'm even going to show you how you can subscribe through to the WebSocket stream and then see in real time in your CLI all of these details and change, etc. This is just a nicer view. Now, going back to the slides, let's continue where we left. So this is the URL where you can see basically all the details about Chainlink Data Streams. Speaking of designs, I already talked about it, but we're gonna just quickly repeat. So difference between push-based and pull-based Oracle models. Data Streams is an example of a pull-based Oracle models, which provides low latency delivery of market data off-chain that you can verify on-chain much faster, right? And speaking of these two architectures, we can now see their differences on this diagram. So on top of this diagram is essentially the traditional price oracles, where again Oracle networks constantly fetch price data from various different price sources and then calculates them constantly and reaching consensus of those prices, but the delivery will happen only on trigger, cryptographically signed delivery. Of course, we're gonna just write a new transaction on this reference contract. This reference contract will calculate the median value of all of these prices, and that will report as a final price that your dApp can then fetch and consume, and then use it in your logic, and then your users are just interacting with this dApp. On the other side, with pool-based oracles, with data streams, again, there is Oracle Network Dawn doing the same calculations all over again. We saw it in real life. How fast is it? However, your users can fetch price data directly from the Dawn, get those blob reports, and then either display it on the UI as we saw, or if they want to interact with them on chain to do some calculations that are for which price data are needed, then we'll just provide those reports to the verifier smart contract I mentioned. And we can see here that users are basically communicating directly with the DON. We have a Data Streams SDK that I'm going to showcase to you, written in either Go or Rust. So if you're familiar with Go or Rust, you can use it. We're working on a TypeScript version as well, if TypeScript is your language, just is not ready and live yet. Using those SDKs, actually the same SDKs, basically the same specs, just different language. You can make HTTP GET requests, like for example, get the latest report or get the report of this feed ID in this particular timestamp, or get the reports of array of feed IDs, etc., like bunch of stuff like that, or just open a WebSocket and constantly receive a flow of data. We also have a function to compress these reports because it's handy for Solana, for example, but that's a story for another time. If you need compressed reports, you can also get them. However, if you don't have the access to keys, to credentials, to use these SDKs, to get the access is just simple as filling a form at our website I'll show you. But it's like you will need those keys just to prevent DDoS attacks and stuff like that. So if you don't have those, or you want to try it right now, but you need to wait for a couple of hours for your request to get approved, then you can combine data streams alongside with Chainlink automation. That will be the second example for today. And there is a new trigger called log trigger, basically in Chainlink automation. The log trigger basically listens for specific events from a specific smart contract, and you can even filter those events by topics. So topics is literally, if you put the indexed keyword in Solidity, that's one of the topics. You can have 3 indexed keywords, or even 4 if you make the event anonymous. But for now, let's take that you can filter by 3 topics as well. And what automation will do is whenever those filter events from those smart contracts get emitted, it will trigger an action from the automation side, and it will ping your smart contract, and then your smart contract can just revert with a specific error based on one EAP I will show you, and inside that error you will provide feed ID or timestamp or whatever, and just say, hey, I want the price of this feed ID with this timestamp or latest timestamp, however you provide it, from Data Streams DON, and then automation, which has access to the Data Streams DON, will get this unverified report for you, and inside the perform upkeep will deliver it straight to your smart contract, and then your smart contract can just unzip, unpack that data, automatically call the verifier smart contract if you want, pay for the usage at that time, because you need to pay for now, you need to pay directly from smart contract when you call the verify function of the verifier, sorry, and then you will, as a callback, receive a price, and then you can do bunch of cool stuff like perpetual futures, options, prediction markets, and stuff. So this is basically the simple diagram. So instead of in the middle being you as a user communicating directly with the data stream DONs using SDK, you can just outsource that work to automation DONs and just put your smart contract on airplane, which exactly is what GMX is doing. For example, one of the premium users, probably one of the most popular users of data streams. What they do is that when they want to settle a new trade, they will emit a certain event with trade ID, order data, etc. Automation DON will pick up that event, request price data from the data streams DON, and automatically automation DON will fetch and sign that price report, and then deliver it to the GMX contracts back again. And that GMX contract will call the Chainlink verifier smart contract up here. It's currently on Arbitrum, that's why it's that on the blockchain written here. And basically they will get as a callback the price data, and then using that price they will settle this trade, for example. And this is pretty much it. I will show you a simplified version of that example and another one, and everything's written and everything's hosted here at GitHub. So this is my GitHub, Andrej Rakic. /data-streams-workshop. I'll send you a URL, or you can just type it. And for now, I'm going to stop share my screen, share the other one with the GitHub, and then we're going to continue with the hands-on part, which I think is much more interesting than just me blabbing in the camera. Of course, if you have any questions, again, you can ask them directly, or follow me on Twitter on Andrej_dev, and I'll follow up with you afterwards. So you'll find this repo on GitHub. This is the one I was talking about, and you can see it's literally updated 3 hours ago. So it's freshly delivered for this workshop. You can see it's mostly Solidity plus a little bit of Rust. So I think it's going to be quite interesting for you guys. What I'm going to showcase to you today is 2 examples. The first one is, and 2 different ways of interacting with Chainlink data streams. The first one is what we call streams direct, is when you are communicating with the data streams DOM directly using SDKs. And the second one is streams trade, is when you outsource that to Chainlink automation, and you basically combine Chainlink automation and Chainlink data streams to get price reports. Because you can see repo is not too big. It has a couple of files and a couple of contracts. I'm going to show it to you. You can see, but for simplicity, for each of these 2 examples, I literally linked down here the relevant files. So if you want to look at them, so for Streams Direct, we will have this smart contract. I'm going to showcase to you in a minute, and this Rust file, which use the Data Streams SDK, the Rust version of Data Streams SDK, to get the price data. You can also use the Go version as well, whatever it's more convenient to you. I chose Rust because I'm literally the engineer who created that one, so it's like a little show off, basically, a brag or something. And also, what I'm going to showcase to you is the usage of 2 different types of reports. We also have V1 and V2, but V1 is deprecated. V2 is not heavily used. So you'll either gonna choose between V3 or V4. V3 is cryptocurrency streams, so basically cryptocurrencies, and V4 are real-world asset streams, so RWAs. And I'm gonna show you the difference today. This is the URL to the Data Streams SDK, if you wanna take a look. So I'm gonna share this tab instead. So this is the SDK. So Smart Contract Kit Data Streams SDK. So Go and Rust versions. I chose the Rust one because I'm more familiar with it, basically, because I created it from scratch. And here you can see how you can use it and stuff like that, and documentation and whatnot, blah, blah, blah. But I'm going to show it to you, the basic example, when you're just getting the latest report of it in terms of USD feed. The second thing that I'm gonna showcase in this example is how you can test it. So we recently created also Chainlink Local, which is a way to test all of your Chainlink integrations locally. And if I go to GitHub and type and search for Chainlink Local, you will see this repo, and basically you can use Chainlink Local with Foundry, with Hardhat, and Remix to test a bunch of different services from Chainlink. We started with a service for testing CCAP integrations, and that's why you see like example of CCAP Local Simulator over here, because it's one of the most let's say, it's not that trivial to test cross-chain flows locally, and that's why we needed something as Chainlink Local to help us. That's literally a dedicated section in documentation for Chainlink Local. However, if you go to releases and find this one, the latest one that I'm gonna publish pretty soon, this one adds supports for data streams, and it's almost mature. We're planning to support it. And over here, because it's not live in the docs yet. You will see how you can use data streams in all of these different frameworks, or you can just follow up the workshop and I'll show you. So that's pretty much it for the first example. For the second one, we're going to use Streams Trade. So this is combination with Chainlink automation. Over here, we're going to, instead of end-to-end test that we're going to have in the first example, where we're literally using the actual data from the SDK, and we're verifying against the actual copy on fork on scroll Sepolia of the verified smart contract. Here is just the unit test to validate our basic logic, and we're going to mock the calls from the Chainlink automation. And I'm going to show you how we can use just unit testing with Chainlink Local data streams over here. Okay, cool. So that's pretty much it. We're going to just run these tests, and you can also deploy this to testnets if you want. And for now, I think I can share. Is it better if I share my Visual Studio Code? Let's see. I think it's going to be more beneficial if I just share my Visual Studio Code instead of GitHub. Okay, you should be able to see this. Okay, this is the README I was showing to you. Okay, cool. So I'm gonna just zoom this a bit so it's easier to follow along, like this. We don't need terminal for now. And as we said, the first example is just the verifying of the price report. So this is the smart contract that I'll use as a base to verify price reports coming from data streams down. Let's put it like this so it's easier to follow along. A couple of interfaces just to call the actual functions, and the main code. So first of all, I said to you, you can use either V3 reports, so cryptocurrency streams, or V4, which are real world assets. And you can see that, you will see actually that these first 1, 2, 3, 4, 5, 6, 7 members of these structs are basically the same. You can see here and this one are the same. What's different is in V3 we have, after price, we have bid and ask, which I mentioned, briefly mentioned earlier. And here, instead of bid and ask, we have a market status. So feed ID, just the unique identifier, couple of timestamps, so earlier timestamp and latest timestamp for each price is applicable. Then fees, you can pay for fees in either a link token or a native coin on that particular blockchain. So whatever it's easier for you, you can just use maybe message.value or wrap it or whatever. Then you can see another timestamp, which is basically the latest report, when the report can be, latest timestamp where the report can be verified on chain. So if the current block timestamp is greater than this one, then the call to verify smart contract will fail. So be aware of that. The actual price, this is what we're looking for. It's a consensus median price on either 8 or 18 decimals. However, for cryptocurrencies, you also have this bid and ask. We saw that with Bitcoin, for example. And those are like simulated price impacts of buy order up or sell order up in the percentage depth of liquidity utilization again. So let's say 0.2 or 0.5% lower and higher, for example, than the current price. I think that's probably the most easiest way to understand this. For real-world assets, instead of bid and ask, we have a market status, which is consensus on whether the market is currently open or not. So it can be unknown, closed, or open. For example, some markets are closed during Christmas night or something like that, or rarely, but some are closed during weekends. For example, you cannot trade during weekends. You need to wait Monday at 7 or 8 a.m., for example, for market to open and stuff like that. So what we want is actually to verify that the market is open, and if not, then to either pause or wait with our logic or just revert transaction or whatever. So we don't spend our fees for nothing, basically. Over here, there is a verifier smart contract, address of a verifier proxy smart contract, and this is the important one because we are calling the verify function use on this particular address, and this address is different from chain to chain. So if you remember the README at the very bottom, I said, okay, when you're using these commands to deploy this to scroll Sepolia, as you can see, I use the hard-coded address of this smart contract on scroll Sepolia testnet. However, if you want to do it on scroll mainnet, the address will be different. So you can always want to go to this link linked in the README to get the actual price, to get the actual address, apologies, from the official documentation, basically. And over here, we're not doing much. We're just deploying this smart contract. And this is the core logic, basically. So this one function, verify report, I put a warning that anyone can call this function and consumes links for report verification fees. And for production control, you must use access control. It's just so we can have less code to see the actual logic that we are interested in. So first of all, we are gonna, so unverified report that we're gonna receive from Data Streams Dawn is just a huge bytes data, huge blob of data. We want to unpack that one. First of all, we will need fee manager and reward manager, just addresses to handle fees. And then we're unpacking the unverified report. So we are interested in this bytes report data. This is just some array of bytes 32 values for context matter, and there is a couple of bytes at the right that we're not interested in. We are interested in report data. Each single report starts with a certain values. So for 0x0003, then whatever, let's say Bob or whatever, it's the ID, potential ID of Data Streams feeds. So all of those V3 cryptocurrency streams will start with 0003. RWAs will start with 0004 and then blah, blah, blah. Version 2 will start with 0002, obviously. Future versions will start with 5, etc. So what we are doing here is we're basically shifting bits to extract this part over here so we can see is report version 3 or report version 4. This smart contract supports only these two report versions. Otherwise, it will revert. That's because we have only structs for these two schemas. That's what this line does. Then we're just gonna get the fee token address. You can either, from the fee manager contract, you can either get the link address or the native address. I decided to pay my fees in link because I will get a discount if paying in link, so it's cheaper for me. And over here, I'm just gonna call the same smart contract, yes, to calculate the fee and potential rewards. Rewards are now 0, but to calculate, I think, maybe I'm wrong, but to calculate how much I need to pay, let's put it that way, to verify this report data, and I'm paying with this token, and this will be the payer. So I'm literally going to lock my tokens inside this smart contract and pay as I go. You can maybe handle that differently. When I get this fee, I'm just going to approve the fee token address, the second address from top, the second one. Actually, sorry. Yeah, the second one, reward manager. I'm going to approve reward manager to spend some of my links. And that will happen when I call the verify smart contract as part of it. So this is the most important step. It's a crucial one. So here I'm providing unverified report. I'm paying with link, and I'm calling the verify function of the verifier proxy smart contract. If everything's go well, I will receive this verified report data back. So verified report. And then I can consume that verified report. And if it's report version 3, then I can decode it as my struct report 3 with 3 schema, if not as v4. That's why I have those two structs. However, what I will do is I also want to validate a couple of stuff. this is just something that it's highly recommended to do in production. So what I want to do is to verify that bid and ask are legit values. So not just price, but also bid and ask, because I'll probably use them in my calculations. I want to make sure they're greater than 0. Also, bid must always be greater than ask. So bid is greater than price and price is greater than ask. So I want to validate that thing as well. And finally, I'm just going to emit the price, but I'll return the actual price from this smart contract. So that's for cryptocurrencies. For real world assets, I'm interested whether the market is open or not. So here I'm checking the market status instead to make sure that the market is open. If it's not open, so if it's either closed or unknown, I'm not going to take any chances. I'm just going to revert with market not open error. However, I will still spend link for verification purposes, even if this step failed or did step. So be careful. And yeah, of course, emit event and just return the same price. And this is pretty much it. This is the core logic of here, and I'm just using the same smart contract in my second example. I'm just inheriting and this functionality and building on top of it. So if you understand what this stuff does, you're basically understood Chainlink data streams. If not, I'm obviously here to help. This is just some logic to handle payment in either link or native or wrap native assets for fees. It's standard Solidity. We don't care about it. Cool. So this smart contract, we can see here that anyone can call this function and anyone can provide this unverified report. But we need to get this unverified report from somewhere. And for those purposes, we will use this Data Streams SDK, particularly the Rust version. So this is probably the most simplest function that we can call. This SDK is much capable of much more. But over here, what I'm doing, I'm getting these two credentials, so API key and user secret, that I need to communicate and to authenticate myself to communicate with the data streams done. And I'm just going to use this REST URL. So I'm going to ping this endpoint, which is REST API endpoint, basically. You can also subscribe to the stream of we're using WebSockets using this URL. I'm providing the feed ID, ETH into USD. This is on testnets. And we can see, again, it starts with sequence of 0x0003, meaning it's a version 3 of data stream schemas. I'm just initializing some config using all of this data, using build pattern, and creating a new client of this SDK. And then you will see in the documentation of the SDK, but client has multiple different functions. The one I'm interested in is get latest report, which will essentially make a get request to this endpoint. Just get the latest report of this feed ID, and I'll just print line the full report payload, that whole bytes chunk. This SDK obviously has functionality to decode these payloads, etc. But if we remember here, our smart contract expects this unverified report, the whole payload, to be passed here, and then we are going to unzip it after we verified using the proxy. So then with the verified report, we're going to decode it to the correct report. So what we can do now is just, I'm going to show you how this is going to look like. So I think I can just run cargo run get latest ETH USD report, if I'm not mistaken. Yeah, here it is. So this is the unverified report. It's literally like just a blob of data. And there's like a bunch of other stuff we don't care about. Maybe that's a topic for another time. We don't have time now, but I can basically explain to you how to decode it and what all of this means. But let's say that for now we have this giant hex value, giant-based bytes data type, bytes variable that we can pass to the client's verifier smart contract to the verifier report. After we're gonna pass this thing to the verified smart contract, and what we want to get is the actual price. So let's get to that step now. We can obviously test this on testnets, on production, whatever, but it's much easier if we first start testing with Chainlink Local. And over here, there is a third file, streams direct end-to-end test.sol. Actually, this is the fourth file. The third file is cargo.toml. So this here is just a simple cargo for this simple Rust file. And over here, you can again see how you can install SDK, and for performance reasons, I just used downloaded the code needed for and functionality needed for REST API. I'm not using WebSockets for now, so that's something that you can literally copy paste from here. Okay, so let's do it like this. So this is our basic end-to-end test. Over here, we are creating a fork in Foundry of Scroll Sepolia testnet in the latest block at that point. We're going to basically create and select that fork. So for these purposes, I put the Scroll Sepolia RPC URL to my .env file, which I'm not going to show you. But over here, for Scroll Sepolia RPC URL, I put my RPC URL. For example, I used Alchemy, but maybe you can use another service or whatever. You just need an RPC URL for Scroll Sepolia testnet that supports archiving. I can show you later how you can get it from Alchemy. And ScrollScan is also for deployment. So if you want to deploy this on Scroll Sepolia testnet, you go to ScrollScan, create your profile. It's really simple, and get the API key, and you can put it here. For now, you don't need it for this test, but if you want to go with the deployment steps, then it's going to need it. So for now, only Scroll Sepolia RPC URL. And I grabbed this address, which is a verified proxy scroll contract on Scroll Sepolia from the official Chainlink documentation. So again, put the link in the README, or you can just go to the docs and find it. It's really simple. So you'll find a list of 4 blockchains, go to Scroll Sepolia, find it, and you will see this address. Finally, I'm just creating a new instance of this client reports verified smart contract we already saw. And we can see that accepts only one address in constructor, which is the address of a proxy, of course. For testing purposes, because we're doing literally on a fork of chain, I created this helper function that will request a couple of links, 5 links from faucet. So this is the address of a faucet of link token on support. So if you go to faucets.chain.link, funds will be sent from this exactly same address. So you can just simulate that step in your test. Normally, you will go to the faucets.chain.link to get a link, and also scroll Sepolia coins if you need them. Yeah, so this is the main step. I'm gonna go back to this function again. So this is the test verify report. And over here, I'm just validating whether these 2 environment variables are set. If not, this test will be actually skipped. So if you see yellow skip, that means that that's why the test was skipped. As a sanity check, I'm just validating that I created the correct fork and that I'm on Scroll Sepolia, which I am. And again, requesting link from faucet to get 5 links directly sent to my smart contract. And then I'm trying to get the report. So first of all, I'm going to call this get latest report from Data Streams done. This is a helper function from here, which using the FFI flag will execute the cargo run get latest ETH/USD report. So this command will be executed again in the terminal. And after it processes everything, it will console log or print line this blob. So after that, I'm just going to remove these string quotes because I don't need them, and just return the actual blob like this. So the actual price report over here from this function. So when I get this result, because it's string, I'm just going to parse it as bytes, because essentially it's bytes, but it's written, displayed in string in terminal, because that's how terminals basically work. So I just want to convert that to bytes. And then I'm going to pass that payload to our verify report. Our verify report will do a bunch of steps we saw, and hopefully return a price. What we're going to do is console log this price, just so you can see it in the terminal, and most importantly, assert is greater than 0. So it's like the valid price. So to do that, I'm just going to run forge test vvv so we can see the console log and hit enter. And we're now waiting for here is the Rust script to execute. And here it is. So we got the latest price, which is this value. Here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I know that this feed has 18 decimals, and that's why I just shift the dot to 18 decimals. So the latest price at this particular moment is that 1 ETH equals this amount of US dollars on a testnet. So for example, so that's the price. And then, okay, here I just console log it, or from this function, I just return it. But in your production, depends on your use case, you might want to scale it, decimals, whatever, that's up to you. But this is the actual price got directly from the data streams done using the SDK and tested integration using using the Chainlink Local directly from here, right? Cool. So that's step number 1. That's example number 1, actually, where we communicated with the data streams done directly, verify that price, and then depends on us, we're going to use it later. The exercise number 2 is so-called streams trade, where we combining automation with data streams. So for streams trade, I'm going to open this smart contract. And let's see, what do we have here? So over here, I'm importing client reports verifier smart contract, the very same smart contract from last example, because again, it has the function to verify the report. So I'm just gonna build on top of this smart contract, and you can see here how I inherit that one into my new one called streams trade. Also, to make this smart contract compatible with Chainlink automation, I'll just import iLog automation interface and streams lookup compatible interface from the Chainlink contracts package. So that's needed because automation done will call specific functions on your smart contract with specific signatures in order to communicate with you. So that's why we need to import this interface. Basically, we need to import those functions so we tell the automation done what to do and how to automate our smart contract. Over here, we have this initiate example thread. So if you remember my last slide where I showcase you the GMX example with data streams, we saw that they do, when they're creating a new trade, they do a bunch of stuff, and then at the end they emit event, so automation or their custom bots can pick that information and request price data from data streams done and then pass it back. So over here, we're just simplifying everything. This is just for testing purposes and for demo purposes. We are emitting just one event that's going to be picked by automation done to continue with the process. That's simple as that. And over here, just to showcase to you how you can build more complex use cases, I providing this feed ID in event as a topic filter. In example from the docs, I think there is no such an example in data streams, at least. There is on other places, so that's why I put this one a bit more advanced. So after that event gets emitted, automation done will call the check log function. So it will provide the log, which is essentially EVM log, right? So it's just a Solidity struct populated with all of these details like index, timestamp, block number, hash, transaction hashes, etc. And most importantly, topics and the rest of the data of the log. So they'll pick like log from the blockchain, put it in this struct and call the checklog function, plus additional data if you want. This is the data that you will set up during the creation of automation, and it will pass every single time when the check log is called if you want to have some more advanced calculations in your smart contract. This function should return either upkeep needed, like a Boolean value, or perform data in general case when you work with check log, when you work with log trigger automation. However, if you check for EAP 3668, so EAP 3668, that's universal standard when you're working with this type of oracles. Instead of returning upkeep needed or perform data, it must revert with this specific error, streams lookup. And what we are reverting here is the feed IDs and timestamps, so just strings, so feed IDs and then the array of feed IDs, and then timestamp and the actual timestamp from the log, and you can provide some extra data. We don't need them. Instead of like hard coding feed IDs as a storage variable or passing or stuff like that, I decided to get the feed ID directly from the topic to show you how you can do it. And essentially, this is how you can grab that topic and just convert it to hex string, because again, this needs to be all in strings for some reason. After this error gets reverted, this is a signal for automation to ping, for automation done to ping the data streams done to get the latest price report of this particular feed or these particular feeds, because this is actually an array, so you can provide more feeds. And then this is going to happen. So a little bit of me drawing ASCII diagrams. So this error is going to get reverted. Then automation done will ping data streams done, and then it will ask itself, is the call successful or was the call successful? So if yes, great, we have values, which is that blob we saw when running that Rust script, for example, plus extra data if needed. If no, then again, we have something returned from data streams done plus extra data. The only difference is which function we're going to call. In successful scenario, we're going to call check callback. In unsuccessful scenario, we're going to call check error handler. And check error handler is the optional function. Again, you can totally go without check error handler. However, I decided to include it because both of these are designed to be as pure functions, so it won't cost any gas, but can be a really nice signal for you whether you want to retry with pinging the data streams done, or totally revert this call or proceed as usual. Perform upkeep is the function that will cost gas, and this is the function that will actually deliver the price report to your calling smart contract. So let's deep dive into check callback and check error handler function implementations. So first, successful scenario, check callback. Extremely simplified. Just we're going to indicate that report success was true, and we're going to just ABI encode the values. This is the bytes array of data fetched from the data streams, plus some extra data. If you set them up, probably it will be empty, and just return all of that directly from the check callback. That thing returned from the check callback will then be picked by automation done and passed here to perform upkeep as a perform data. What's interesting is if there was an error when pinging data streams done. Again, this is a new optional function, which is meant to surface streams lookup errors. This is just an example. So, like it's totally up to you how you can customize it. At this URL, however, you'll find all the different error codes possible, so you can plan accordingly. So what we're going to do here is, at first, the report success will be false. And then if error code is 0, that means that there is no error, and just we're going to return true, everything's cool, whatever. If we have either of these two error codes, so 80840 or 400 or 808-401, that means that that was either a bad request or incorrect feed ID. And at that point, we can say that upkeep needed can remain true, but report success is false, because we still need an upkeep, we still need a price, but we provided inaccurate data. We provided a wrong feed ID. We maybe mixed the feed IDs from testnets and mainnets and stuff like that. Obviously, there are much other different error codes, but for all the rest, we decided to just explicitly say false. And this is just for simplification reasons, for demo purposes. You can also handle this much more gracefully. Maybe you can just, for example, again, try to request another round of price report from data streams, etc. Maybe you don't want to go into risking you go into infinite loops. Totally up to you. For now, we said everything's false, so success was false, and upkeep needed is false, so it's not needed. Just stop with everything. Okay, cool. Finally, in perform upkeep, what we're going to do is that we're just going to decode this data, and if report was successful, so here is true, but here can be false, true, or true, then if it wasn't successful, we are going to just for now just store this error code in this storage variable, which is extremely dumb thing to do. Actually, what you want to have here is that custom logic to handle all of these errors. Again, re-requesting price or whatever you want to do, that's totally up to you. So that custom logic is happening over here. If it's successful, then it's much better solution. Over here, we are gonna grab the signed reports, because again, we are requesting the reports in form of ID in form of array of feed IDs. Even though I just have one ID, it's still passed in array. As you can see here, it's where is it? It's feed IDs. It's literally feed IDs of 0. So first element of this array, and from there I'm just gonna grab the first element for my use case. So that's my unverified report. And then what I'm going to do is just call the verify report function on that other smart contract I already show you. We already saw this one. And because this one will return price, over here, I'll just get that price and again, store it in a storage variable. You probably won't do that in real life scenario. This is actually a dumb thing. You're just storing it in a variable. But this, again, is for demo purposes to have much less code. Obviously, if you initiate trade, for example, by emitting event, at that point, you will get the price and then maybe continue with the trade execution or close the position or whatever you want to do. That's totally up to you. Final thing that I want to show you is how you can test this locally again using Chainlink Local. Now we're just writing a unit test, like a simple unit test. And again, I'm importing Data Streams Local Simulator and mock verifier proxy. So the mock version of the verifier proxy, not the actual contract, which is handy for testing certain edge cases. And also I'm importing, again, from Chainlink Local, I created this mock report generator. So because you're not interacting with the SDK and you don't want to think about generating reports or whatever, you can just generate mock reports as you go and on and tweak some certain parameters like price or bid and ask or market status or timestamps, whatever, and make your tests much more flawlessly. So here as initial price, I just put 1 ETH, and I'm just initiating some address to act as my mock automation forwarder. Here from the configuration function of Data Streams Local Simulator, I'm going to grab the mock verifier proxy and just use it as a construct argument for my smart contract. Here is how we're going to test the whole flow. So again, first of all, I'm just going to generate the mock report so I can get it will return me sign report, which is that bytes data, the thing we saw in the terminal with rusting, for example, and also the actual report struct v3 or v4, that depends on the function signature, that I can actually see the report, which is a mock, the generated one. Why I need this? Because maybe I want to provide the feed ID here or to assert against report price from here at the very end. Initiate example trade is just function that calls this, that emits this event, which is a trigger. And over here, we're just asserting that initially price is 0. And then written price of storage variable, sorry, is 0. And then we're just pranking this address to act as automation done, which will get the values from this signed report, which does get the actual price report from the whole thing. And over here, call that famous check callback function, because here we assumed that wasn't the error. Actually, it wasn't, because we generated the mock report, so it wasn't any error. So we called check callback. This is a happy path. So we're calling this function, and then this function just will return certain data. We're interested in perform data, and after we're interested in perform data, upkeep needed is true. And then we automation done in flow in a process will just call the perform upkeep function directly. And that's what I'm doing here, calling the perform upkeep. And that's pretty much it. And it will deliver the price. What I want here is to decode that last decoded price is actually equal to report price. And what I can do more is just to console log this, so you can see it in test instead of just trusting me. So again, forge test vvv. Oh, let's just to recompile everything, and we can see that initial price, which was 1 ether, so 1.18, is console logged here, and the test is successful. So this is how essentially you unit test this behavior. So we're on time. What just wanted to tell you and didn't have time is that when you're working with automation, you go to automation, then you go to register new upkeep, then log trigger to create a log trigger, then contract that emits arrays, that emits events, the contract that want to automate. So we're gonna.
Oh, I think you're not sharing your screen anymore. If you wanna.
Okay. Sorry. I just wanted I need a minute just
Yeah,
show
no
you
worries, no
the
worries.
thing that I did in tests. So if you want to use data streams with automation, you're going to hit register new upkeep, hit the log trigger, that's the third trigger, and hit next, and then contract that we want to automate, that is going to have the verification stuff like that. We have a green check mark, meaning that it's automation compatible contract, and also contract that emits logs. In our case, that's the same one, but you can listen for different events. Maybe you're creating a bot that wants to do MEV stuff, and then you're listening for events from DEXs, whatever. In our case, it's going to be the same thing. Because it's a verified smart contract, ABI is fetched. So I'm going to just hit next. And here we need to select which events we want to list. We are listening to new trade event. And here I can index, you can see, because I have topics, I can specifically filter just a specific feed ID. If I leave this empty, will apply no filter. So I'll just pick every single new trade event and hit next, and then a couple of config details, register upkeep, and then you are good to go. And that's how you can do this and replicate this behavior on testnet as well. Whew, this was
That was a lot of information. Okay, I do have questions just to kind of squeeze in a few things. One of our tracks is for RWAs. I know you have RWA streams. Do you have any content around tokenizing RWAs that you can then use for?
Yes, actually, I hosted a workshop around tokenized real-world assets. I'll try to find the link for you.
Yeah, you can always send them after me. I have the
Yeah.
Scroll Builders chat if you're not in it. Comment on Twitter and then I'll send you the Scroll Builders hat. But yeah, if you can send that to me and then I will disperse that to all the other people. The other thing I wanted to ask questions about Chainlink automations, is it only for price so we can't do automations for general data?
Oh, you can.
You can?
So yeah, we saw that there was log trigger, but there was two others. So the other one is time-based upkeep. So you literally select specify a cron job. Let's say you want to call this function daily. to write GM somewhere, or you want to call it monthly, like a last business day of a month. So you want to distribute salaries to people in
Yeah.
business, stuff like that.
Okay.
So you
Okay.
can do stuff
Awesome.
like that. Yeah.
That is
And custom base. Custom base is literally whatever you want.
okay. Okay. Awesome. And then third piece, the local testing environment that's cross chain is super cool. Can people just use it forever, however they want? It's just like, or does it need to be
Yeah.
Chainlink specific?
Yes,
Okay.
we actually have customers like Gnosis, a couple of banks actually using it for CCAP. Also, that's one created just by myself. So if you
That's
break it,
super
just ping me
sick.
on Twitter and I will fix it or
Yeah.
whatever.
Yeah.
If you have a
Cool.
feature request or whatever, I'll try to be supportive as much as possible.
Yeah. Awesome. Yeah. Easter egg when I used to work on like the truffle ganache team, we were building cross-chain local testing environments.
Oh,
So
really?
yeah,
It's
yeah, yeah,
fun.
yeah. It's hard, but it was so necessary. It's even more needed now than like back when I was on that team. But
Yeah,
anyways, okay, cool. Thank you so much for joining. I wanted to plug one last thing. Open.scroll.io is still, I guess, up for registrations, but it's only through a referral system. So if you're here with us, Chainlink will use as your referral code, and I guess find us there for your chance to, I guess, win a cut of the prize, but also meet us IRL in Kuala Lumpur afterwards for a accelerator program. So, anyways, thank you so much for joining, Andrej. If you can send all the information that you have, and I'll post the links in the
I
relevant
will.
places. Okay,
Thank you for having me,
cool.
Emily, and good luck with hacking, guys.